What is up, you guys? It's your boy, Edgar Studies, and today we will be taking a look at a physics problem on gravitation. I do feel that Earth always gets the attention in these types of problems, so we are going to be switching it up today and focusing on the moon. So without further ado, let's get started. So the problem is, calculate the period of a satellite orbiting the moon 120 kilometers above the moon's surface. Ignore effects of the Earth. The radius of the moon is 1,740 kilometers. So this is an image representing the problem we are solving. We will attempt to find the period of the satellite or the time needed in order for it to complete a single orbit around the moon. Before we dive into finding the period, it is important to know how to find the speed of a satellite. Since we assume our satellites move in a circular orbit, we are able to apply the physics of circular motion. The difference is that gravity will be providing this centripetal force. In these equations, big G is the gravitational constant, the big M is the mass of the planet or moon, the little m is the mass of the satellite, r is the radius of orbit, and v is the velocity of orbit. So if you just take a look at the screen, you will see that the velocity will turn out to be the square root of the gravitational constant times the mass of the planet or moon divided by the radius of orbit. So now to find the period denoted by t, we take the distance traveled by the satellite and divide it by its speed. The distance traveled by the satellite, assuming circular orbit, will be 2 pi times the radius. The speed, as we saw previously, will be the square root of the gravitational constant times the mass of the planet, or in this case the moon, divided by the radius of the orbit. Once we put these things together and simplify a bit, we find that the period is equal to 2 pi times the radius to the 3/2 power divided by the square root of the gravitational constant times the mass of the moon. So now for this next part, we can use our calculator. So if you're crunching numbers along with us, comment down below what kind of calculator you're using and its addition, whether it be TI-84, TI-Nspire, etc. Anyways, the radius of the orbit is taken from the center of the moon, which is why we will add the radius of the moon to the satellite's distance from the surface of the moon. Big G is a constant that you should all know, and it happens to be 6.67 times 10 to the negative 11 Newton meters squared over kilograms squared. And the mass of the moon is 7.35 times 10 to the 22nd kilograms. Now we've plugged in these values into our equation for period. We get an approximate value of 7.2 times 10 to the third seconds. And that is the solution to this problem. If you like this video, please make sure to drop a like, hit that subscribe button, and maybe comment down below what kind of questions you'd like to see in the future.